Natural history documentary, The Story of Life on Earth. Imagine standing on Earth billions of years ago, long before humans walked across its surface, before forests covered the continents, before dinosaurs ruled the land, and before even the first familiar animals appeared. The planet beneath your feet would have been almost impossible to recognize. Continents were moving, oceans were forming and disappearing, volcanoes were shaping the landscape, and the atmosphere was slowly changing. Yet within this ancient and restless world, something extraordinary was beginning. The long story of life. Earth is more than a planet of mountains, oceans, forests, and deserts. It is a living world shaped by countless generations of organisms. Every tree, bird, insect, whale, and human being is part of a history that stretches back billions of years. The natural history of our planet is a story of survival, adaptation, extinction, and transformation. It is a story written not in books but in fossils, rocks, genes, oceans, and living ecosystems. Our journey begins roughly 4.5 billion years ago, when Earth formed from the material surrounding the young Sun. At first, the planet was a violent place. Its surface was extremely hot, and collisions with other space objects were common. Volcanoes released gases into the atmosphere, while the cooling surface gradually allowed water to collect. Over immense periods of time, oceans formed and the planet became a place where chemistry could eventually give rise to biology. The exact origin of life remains one of science's great mysteries. Scientists have several ideas about how the first simple living systems emerged, but no one can yet describe every step with certainty. What we do know is that very ancient evidence points to life existing on Earth more than 3 billion years ago. These early organisms were microscopic and simple compared with modern plants and animals, yet they changed the planet forever. For a vast period of Earth's history, life remained dominated by microscopic organisms. Among them were ancient photosynthetic organisms that gradually influenced the atmosphere by releasing oxygen. Oxygen was extremely important because it made possible new forms of metabolism and eventually supported increasingly complex life. But Earth's history was never peaceful. The planet experienced enormous environmental changes. Continents moved, oceans changed, climates shifted, and volcanic activity repeatedly transformed ecosystems. Life responded by adapting, spreading, disappearing, and evolving into new forms. Around 540 million years ago came one of the most remarkable periods in natural history, the Cambrian explosion. During this interval, many major animal groups appeared in the fossil record. The oceans became filled with unfamiliar creatures, including armored animals, strange predators, early arthropods, and organisms with primitive forms of eyes and nervous systems. The seas were the great stage of early animal evolution. Life had not yet conquered the land in the way it would later. Underwater ecosystems were developing rapidly, and competition between predators and prey encouraged new forms of movement, protection, sensing, and feeding. Eventually, plants began spreading across land. Small early plants transformed barren surfaces into increasingly complex habitats. Fungi and other organisms also became important parts of these developing ecosystems. As vegetation expanded, animals followed. Among the earliest animals to make significant progress on land were arthropods. Ancient relatives of insects, spiders, and other groups explored the new environment. Later, vertebrates also began making the transition from water to land. Fish had already become highly diverse in the ancient oceans. Some possessed features that eventually became important in the evolution of land vertebrates. Over millions of years, certain fish-like animals developed stronger structures for supporting their bodies and adaptations that helped them survive in shallow water and eventually on land. The emergence of amphibians represented an important stage in this transformation. These animals could spend part of their lives on land, but many still depended on water for reproduction. Later came the reptiles, whose adaptations allowed them to become less dependent on aquatic environments. The ancient world continued to change. Forests expanded, enormous plants covered parts of the continents, and oxygen-rich periods supported some remarkably large arthropods. But once again, Earth experienced a devastating environmental crisis. Around 252 million years ago, the Permian mass extinction caused one of the greatest losses of biodiversity in Earth's history. Vast numbers of marine and terrestrial species disappeared. The causes were complex, but enormous volcanic activity, climate change, ocean disturbances, and other environmental effects played major roles, yet extinction was not the end of life. It created opportunities for surviving organisms to evolve into new ecological roles. The next chapter belonged to the reptiles. During the Triassic period, ecosystems slowly recovered. Among the surviving and emerging groups were the ancestors of dinosaurs. At first, dinosaurs were only one part of a much larger world containing many different reptiles and other animals. But over time, they became increasingly important. The Jurassic period brought enormous changes. Dinosaurs diversified into countless forms. Some were enormous herbivores with long necks and massive bodies. Others were smaller, fast-moving predators. Their world included giant forests, open landscapes, rivers, and coastal ecosystems. Imagine walking through a Jurassic forest. Tall vegetation would rise above you, while enormous animals moved slowly between the trees. Somewhere nearby, a predator might be searching for prey. In the sky, flying reptiles would glide across the ancient landscape. Beneath the surface, insects and small animals would occupy their own hidden ecosystems. Dinosaurs were not all giant monsters. Many were small, agile, and covered in feathers. Over time, scientists discovered increasingly strong evidence connecting birds with certain dinosaur groups. Today, birds are considered living dinosaurs, meaning that part of the dinosaur story continues in modern ecosystems. The Cretaceous period was the final great age of non-avian dinosaurs. During this time, flowering plants became increasingly important. They transformed landscapes and created new relationships between plants, insects, herbivores, and predators. The world of the Cretaceous was extraordinarily diverse. Giant dinosaurs walked across continents, marine reptiles lived in the oceans, and early birds flew through the skies. Mammals were also present, although most were small compared with the dominant dinosaurs. Then came one of the most famous events in natural history. About 66 million years ago, a large asteroid struck Earth near what is now Mexico's Yucatan Peninsula. The impact triggered enormous environmental consequences. Dust and particles entered the atmosphere, sunlight was reduced, temperatures changed, and food chains were severely disrupted. Many species disappeared, including the non-avian dinosaurs. But some organisms survived. Among the survivors were birds, mammals, reptiles, amphibians, insects, and many marine organisms. With the disappearance of many dominant animals, ecological opportunities opened across the planet. This was the beginning of a new chapter. The age of mammals had arrived. Mammals had existed alongside dinosaurs for a very long time, but after the extinction event, many mammalian groups diversified rapidly. Over millions of years, they evolved into an extraordinary variety of forms. Some became enormous herbivores. Others became powerful predators. Some adapted to life in the oceans, while others returned to the air. Still others developed specialized ways of living underground, in trees, or across open grasslands. The ancestors of whales, for example, were land-dwelling mammals. Over millions of years, their descendants gradually adapted to aquatic life. Their bodies changed, their limbs transformed, and their lifestyles became increasingly connected to the oceans. Today, whales are among the largest animals ever known to have lived on Earth. Their existence is a powerful reminder that evolution does not follow a simple path. Animals can move into completely different environments when natural selection favors new adaptations. Primates followed another evolutionary path. The ancestors of modern primates developed characteristics useful for life in trees, including grasping hands, flexible limbs, and increasingly sophisticated vision. Over time, different primate groups evolved across Africa, Asia, Europe, and other regions. Eventually, one branch of the primate family produced hominins. Human evolution was not a straight line. It was a complex tree containing many species and populations. Some disappeared, while others survived and changed. Early hominins gradually developed different forms of walking, tool use, communication, and social behavior. Millions of years passed before our own species appeared. Homo sapiens emerged in Africa roughly 300,000 years ago. Early humans lived in environments that were often challenging and unpredictable. They hunted, gathered plants, developed tools, controlled fire, communicated, formed social groups, and eventually spread into different parts of the world. But humans were not simply observers of nature. they became a major force within it. As populations grew, humans learned to manipulate landscapes. Agriculture transformed the relationship between people and plants and animals. Instead of depending entirely on wild food sources, humans began cultivating crops and domesticating animals. Settlements grew into villages, towns, and eventually cities. Forests were cleared. Rivers were redirected. Grasslands were transformed into farmland. Species were moved from one continent to another. Human civilization became increasingly powerful, but nature remained essential. Every civilization depended on soil, water, climate, plants, and animals. Natural history therefore continued alongside human history. Across Earth's ecosystems, extraordinary relationships developed. In forests, trees compete for sunlight while roots interact with fungi beneath the soil. Insects pollinate flowers, while birds disperse seeds. Predators control prey populations, and decomposers return nutrients to the environment. In oceans, microscopic organisms form the foundation of enormous food webs. Tiny plankton support fish, which support larger predators. Coral reefs create habitats for thousands of species, while deep beneath the surface, strange organisms survive in darkness around hydrothermal vents. Deserts may appear empty, but they are alive with specialized organisms. Plants store water, reptiles regulate their body temperatures through behavior, insects emerge at particular times, and nocturnal animals avoid the worst heat. Polar ecosystems tell another story. In the Arctic and Antarctic, life has evolved to survive freezing temperatures, seasonal darkness, and limited food. Penguins, seals, polar bears, seabirds, microscopic organisms, and many other species have developed extraordinary adaptations. Every ecosystem is a network of relationships. Remove one important species and the consequences can spread through the entire system. This is why extinction matters. Extinction is a natural part of Earth's history. The fossil record shows that species have always disappeared. However, human activity has increased pressure on many ecosystems through habitat destruction, pollution, overexploitation, invasive species, and climate change. Yet natural history is not only a story of loss, it is also a story of resilience. Nature has repeatedly recovered from catastrophic events. After mass extinctions, ecosystems eventually reorganized and new forms of life emerged. Forests return after disturbances. Animal populations can recover when protected. Rivers can become healthier when pollution is reduced. Damaged habitats can sometimes be restored, but recovery takes time. Human societies operate on years and decades, while natural processes often unfold across centuries or millions of years. This difference in timescale is one of the most important lessons of natural history. A forest may take decades to mature. A species may require thousands or millions of years to evolve. A mountain range may rise and disappear over geological time. Continents themselves move only a few centimeters each year, yet over millions of years they can travel enormous distances. Earth is constantly changing, even when the changes are too slow for us to notice. Look at a mountain, and it may seem permanent, but erosion is slowly breaking it down. Look at an ocean, and it may appear unchanged. Yet currents, temperatures, chemistry, and ecosystems are constantly shifting. Look at a forest, and it may seem stable, but every moment, organisms are being born, growing, competing, reproducing, dying, and decomposing. Life is never still. It is a continuous process. One of the greatest achievements of modern science has been learning to read this hidden history. Fossils provide snapshots of ancient organisms. Rocks preserve evidence of ancient environments. Ice cores record changes in atmosphere and climate. Tree rings reveal information about past conditions. DNA allows scientists to investigate relationships between living organisms and reconstruct parts of evolutionary history. The deeper scientists look, the more connected life appears. A whale, a bat, a bird, a human, and a mouse may seem completely different, yet all are part of the same great tree of life. Their differences are the result of millions of years of evolutionary change. At the same time, their similarities reveal their shared ancestry. Every living organism carries a story. The patterns in its body, behavior, and genetic information are clues to the environments and ancestors that shaped it. Consider the human body itself. Our hands can grasp objects. Our eyes detect light. Our lungs exchange gases with the atmosphere. Our bones provide structure. Our immune system protects us from countless microscopic threats. None of these systems appeared instantly. They are the result of an extremely long evolutionary history. Even the oxygen we breathe is connected to ancient microorganisms that transformed Earth's atmosphere billions of years ago. The world around us is therefore a product of deep time. When we walk through a forest, we are entering an ecosystem built from millions of years of evolutionary relationships. When we watch a bird fly, we are witnessing a living branch of the dinosaur lineage. When we see a whale rise from the ocean, we are seeing the result of a remarkable evolutionary journey from land back into water. And when we look at ourselves, we are seeing one recent chapter in an ancient story. But the story is not finished. Earth's natural history continues every day. New species are still being discovered. Populations continue to adapt. Ecosystems continue to change. Genetic mutations create variation, while environmental pressures influence which traits become more successful. At the microscopic level, evolution is constantly occurring. At the planetary level, continents continue to move, and climates continue to change. The future will be shaped by both natural processes and human decisions. What will Earth's ecosystems look like thousands or millions of years from now? No one can know with certainty. Some species alive today may disappear. Others may expand into new habitats. New species may eventually evolve from populations that exist today. The Earth itself will continue its journey around the sun. Mountains will rise and erode. Oceans will shift. Continents will move. New environments will appear. Life will respond. That is the central lesson of natural history. Life changes. From the first microscopic organisms to the forests of today, from ancient fish to land vertebrates, from giant dinosaurs to modern birds, from land mammals to whales, and from early hominins to modern humans, every chapter has been connected to the one before it. Earth's history is not a collection of separate stories. It is one enormous story. A story of matter becoming worlds, worlds becoming habitats, habitats becoming ecosystems, and life continuously adapting to change. For billions of years, Earth has been a laboratory of evolution. Its pages are written in stone. Its memories are preserved in fossils. Its history flows through rivers and oceans. Its future lives in every seed, every egg, every newborn animal, and every generation yet to come. And perhaps the most remarkable realization is that we are not outside this story. We are part of it. Humans are one species among millions, living on a planet whose history began long before our arrival. We inherited a world shaped by ancient life, and our actions now influence the conditions in which future life will exist. The natural world does not need humans to continue its story, but humans need the natural world. Our food, water, air, and resources all depend on functioning ecosystems. Understanding natural history, therefore, means understanding our own place within nature. It teaches humility. It reminds us that our time on Earth is brief compared with geological time. It shows us that environments can change dramatically, and that even dominant species can disappear. But it also offers hope. Life has survived enormous challenges before. It has recovered from volcanic catastrophes, climate shifts, changing oceans, and mass extinctions. Life has repeatedly found new paths. The question for humanity is whether we will help preserve the diversity of life around us, or accelerate its disappearance. The answer will shape the next chapter. And so, our journey through natural history comes not to an ending but to a pause. The planet beneath our feet is still moving. The oceans are still circulating. Forests are still growing. Animals are still evolving. New generations are being born. Some species are disappearing. Others are adapting. And somewhere, perhaps in an environment we have barely explored, an unknown organism may be waiting to be discovered. The story of Earth is still being written. It began billions of years ago with a young planet, unlike the world we know today. It passed through oceans filled with microscopic life, ancient forests, reptile-dominated landscapes, ice ages, changing continents, and the rise of humanity. And now, for a brief moment in deep time, we are here to witness it. We are observers of a living planet. But we are also participants. The future chapters have not yet been written. They will be shaped by evolution, geology, climate, ecosystems, and by the choices of one remarkable species that has learned to understand the history of its own world. That species is us. And the greatest natural history story of all is still unfolding. Every sunrise begins another page. Every generation adds another line. Every living organism carries another piece of the past. And Earth, ancient beyond imagination, continues its journey through time.